Hi students, how are you all? Hope you all are fine and working hard for your exams. Today let's discuss about force and the turning effect of force. Force is an external agent or a physical cause. It can be a push or a pull which can make a body at rest to start moving or make a body in motion to stop. It can change the direction of the body. It can also change the shape of the body, and it brings a turning effect on a pivoted body. So basically force is product of mass and acceleration. Now we have all studied the Newton's law of motion. It describes the relationship between the motion of an object and the force acting on it. Today let's study the concept behind turning effect of forces. So moment of force is applicable to bodies or objects which are fixed at a certain point. So when a force is applied, they are not free to move away from that position because they are already tied or hinged or fixed at a certain point. So what happens when a force is applied? The only possible movement for them is the rotational movement. So this turning effect of the force is also called a torque. Torque is equal to the product of the magnitude of the force and the perpendicular distance from the line of force to the axis of the rotation or the pivoted point. See, the point where the body is fixed, it becomes the axis for rotation of the body. So we have to take the perpendicular distance from the line of the applied force to the fixed point or the pivot point. So the torque becomes force into the perpendicular distance. Torque is basically a vector quantity because it has got magnitude and direction both. So when the body moves in the clockwise direction, it is considered to be a negative direction, and when the body moves in the anti-clockwise direction, it is considered to be a positive direction. And the SI unit of torque is Newton meter. Now let's see some examples. We'll do some numericals so the concept becomes even more clear. Now let's see the first question. The question says a nut is opened by a wrench of length 25 cm. If the least force required is 10 Newton, find the moment of force needed to turn the nut. Okay. Now see in this question, this is the nut and this is the wrench or the spanner which is used to open this nut. Okay, now length of the spanner is 25 cm, it is given, and the least torque required is 10 Newton. Basically, now we have to find the moment of force needed to turn the nut or to open the nut. Okay. Now see, if we see the spanner, basically we apply the force on the handle of this spanner or the wrench. So this end we have to apply the force. So this becomes the perpendicular distance from the nut. Because nut is fixed at a certain point, so we have to take the perpendicular distance from this nut to the line of force which is being applied at the end of this wrench. Okay, the perpendicular distance from the pivot point is the length of the wrench. So the distance is given as 25 cm. Now we know the formula for the moment of force. This is the product of force and the perpendicular distance. So now this becomes 10 Newton into 25 centimeter, which is basically 250 Newton centimeter. Now if we convert the centimeter to meter, so it becomes 2.5 Newton. That is the answer. So the moment of force will be 2.5 Newton to open this nut. Now let's see the next question. So the question says a meter scale of 100 centimeter is pivoted at 10 centimeter mark and it is balanced by suspending 400 grams of weight at 0 centimeter mark. Now we have to calculate the mass of the meter. Okay. So when you get such kind of questions where you have to find out the mass of the meter, so we have to consider one thing, that the balance of the scale lies at the center. So it is a rod kind of thing, isn't it? So it gets balanced at its center. So if it is a 100 centimeter long meter, then the center of this meter will be at 50 centimeter. So we have to take this as a basic step for every questions which are asking about the mass of the meter, or it can be a rod also. Now this meter scale is pivoted at 10 centimeter. Okay, and we have a weight at the 0 centimeter end, which is 400 gram, and it is hanging from there. So what can happen is either it will go in this direction or it will go in the other direction. It depends upon where the forces are more. So now they are saying this meter is balanced, meter scale is balanced. The meter scale can be balanced only when the forces acting on the clockwise direction and the anti-clockwise direction are balancing each other. Otherwise it will move in any one direction. If the forces are not balanced, it will move in any one direction. So when they are saying the meter scale is balanced, that means it is straight. Okay. So let us assume the mass of the scale to be m. Okay. Now we know this 400 gram weight is hanging from the 0 centimeter point. So this will create a torque here on the left hand side. So now let's calculate the torque which is acting due to this 400 gram weight. So this is basically in the anti-clockwise direction. We can say anti-clockwise moment due to this 400 gram at 0 centimeter will be the force which is being given by this 400 gram weight into the perpendicular distance. So now see, the distance is basically 0 centimeter to 10 centimeter. So the distance will be 10 centimeter. So this becomes 4000 gram centimeter. So the torque on the left hand side due to this 400 gram weight is 4000 gram centimeter. Now on the right hand side we don't have any weight attached. So what is balancing this scale? The weight of the scale itself is balancing it, isn't it? So now the weight of the scale is basically at the center of the scale. So that will be at 50 centimeter. So now let us calculate the clockwise movement due to the weight of the scale. So this will be the mass of the scale into the distance from the center. So the center is at 50 centimeter and it has been pivoted at 10 centimeter. So the perpendicular distance what we have to take is 50 minus 10. So it becomes mass of the scale into 40, which is 50 minus 10 gram centimeter. Okay, now as the scale is stable, we know the anti-clockwise movement is equal to the clockwise movement. So we'll equate these two conditions. So 4000 gram centimeter will be equal to 40 mass of the scale gram centimeter. So now when we solve this, the mass of the scale comes to 4000 divided by 40. So that comes to 100 grams. So this is our answer. Now let's see the last question. So it says three forces A, B and C are acting on a rigid body which can turn about O. As shown in the figure. If all the three forces are applied simultaneously, in which direction will the body move? And we have to explain this. Okay. So this is the body. It has been pivoted at center O, and there are three forces A, B and C acting on it. So now we can see the direction of these forces. Now A is acting in the anti-clockwise direction. B is also acting in the anti-clockwise direction, and C is acting in the clockwise direction. Okay. So now they are asking the body will move in which direction. So we know when the forces in the clockwise direction and anti-clockwise direction are equal, then the body remains stable, or the body is at equilibrium. The body will move in any one direction in which the forces acting are greater. Okay, now see, this force A is at a distance of 2 meters from the center or the pivot point O. Now this force B is at a distance of 2 meters and C is at a distance of 3 meters. So this is the distance of the forces, the perpendicular distance of the forces from the pivot point. Okay, now the body will move in the direction of the net torque. So we'll have to equate the torque on both the sides or on both the direction. That is, we have to take the torque acting in the clockwise direction, and we have to take the torque acting in the anti-clockwise direction, and then we'll have to see the difference. So if the torque is greater on the clockwise direction, this body will move in the clockwise direction, and if the torque is greater in the anti-clockwise direction, the body will start moving in the anti-clockwise direction. Okay, now let's see. The force acting in the clockwise direction is C, and its distance from the pivot point is 3 meters. So the torque will be the magnitude of the force into the distance, the perpendicular distance from the pivot point. So this will be 40 into 3, that is 120 Newton meter. So the torque in the clockwise direction is 120 Newton meter. Now let's see the forces acting in the anti-clockwise direction. The forces acting in the anti-clockwise direction are force A and B. Okay, so the perpendicular distance of A from the pivot point is 1 meter, and the perpendicular distance of B from the pivot point is 2 meters. So the forces acting in the anti-clockwise direction are A and B. So let us find the torque. So this is 60 into 1 meter plus 20 into 2 meters. That is 100 meters. So now see, the force acting in the clockwise direction was 120 Newton meter, and the force acting in the anti-clockwise direction is 100 Newton meter. So we have a net of 20 Newton meter torque acting in the clockwise direction. So obviously the body will move in the clockwise direction. So students, we'll end the session here. We'll cover the other important topics in the next video, and in the next video also we'll do some numericals. Okay, thank you.